Today we will take the last unit, unit 4, and the third lesson in it, the probability. Okay, as we had in grade 5, okay, the meaning of probability. The probability always it's included from 0 to 1. It's from 0 to 1. It means it's included 0 and includes also 1. Okay, let's see here. If I want to calculate the probability of when tossing a coin, if you have a head, what is the probability to have a head? It's half. It's half. How? Because the head is just one outcome from how many outcomes possible in this experiment. It's 2 outcomes. I have only 2 outcomes and head is one of them. So it's 1 over 2. It's 1 over 2. So the probability of getting head is 1 over 2 or half. The probability of getting tail, it's the same. It's 1 over 2. Okay. In a cube or dice, what is the probability of getting even numbers? Okay. In the cube, I have 6 faces. 6 faces. It means 6 outcomes. Okay. 1, 2, 3, 4, 5, and 6. The even numbers, 2, 4, and 6. It means 3 outcomes. 3 outcomes over the total 6. So it's also half. That means the probability is always the thing that I asked for over the total. Okay, this is the outcome. This is the probability. Okay, and always the probability should put in the simplest form. You have to put the probability in the simplest form or simplified. Now I have something called event. Event means any outcomes you can get inside a random experiment are called event. That means if I toss the coin and I got head, this head is called event, okay? And always the event subset of the sample space, as we had in the last lesson. Okay, so event is a subset of the set of sample space. The number of its elements represent number of times of its occurrence. Okay, let's see here. The ratio between the number of elements of an event and number of elements of the sample space is called the probability of occurrence of the event. More abbreviation, probability of the event and is denoted by P. Okay, the probability denoted by P. Probability of event number A or letter A. Okay, the first event. Okay. Number of elements of the event A over the number of elements of the sample space, the number of all the possible outcomes, okay, is the same. So here, this from this exercise, here we have event A, event B. So the example was tossing a regular die once. Observing the number appearing on the upper face, consider the following events. Event A, appearance of an even number on the upper face. Event B, appearance of an odd number on the upper face. So, We have here sample space, as we said before, sample space, all the possible outcomes, which are 1, 2, 3, 4, 5, and 6. And the number of this sample space, it means the number of elements, which is 6 elements. Now, event A, the even numbers, 2, 4, and 6. So, the number of this event equals 3. And the total equals 6. So, the probability of event A equals 3 over 6, which is, in the simplest form, the half. Okay, event B, 1, 3, 5, the odd numbers. It's also 3 elements or 3 outcomes, okay, over the total. So the probability of event B, here, the number of elements of event B over the number of the sample space, okay. So it's 3 over 6 also equals half. Look here, or in both of them, half, okay? It's in the form of fraction, or 0.5. It's a decimal number, or 50%. It's a percentage. So that means you can write the probability in a fraction form, in a decimal number, in a percentage form, okay? So, any of them is correct. Now, let's solve an exercise, okay? Here there is a note. If the results of the experiments are known previously, so they are not random experiment. If I know what the outcome will be, it is not a random experiment, okay? Yeah. For example here, the experiment of selecting a ball from a box contains 3 symmetrical red balls. If I have a box, in this box 3 symmetrical red balls, it means they have the same size, the same touch, okay, and the same color, okay? And I close my eyes and select one. Is it random? Of course not, because I know the outcome before I make the experiment itself. Another one, the experiment of selecting a card from a box contains 5 symmetrical cards. Each of them carries the number 10. So what is the difference between them? Nothing. They are symmetrical in everything. So it is not considered a random experiment. The third one, the experiment of selecting t-shirts from a box contains 20 t-shirts, each of the same size and same color. So no difference. That means it's not a random experiment. Random experiment, it means I have different outcomes. Okay, now choose the correct answer between brackets. If phi is empty set, then probability of getting phi equals 0, 2, 1, or half. The set is empty, so the probability of getting phi equals, of course, 1. Okay, no other outcomes, so it's 1. If sample space or S is a sample space of a random experiment, then the probability of sample space equals 0, 2, 1, or 0.8. S is a sample space, so probability of sample space, I said before, to calculate the probability, you put the number of the thing which you asked, or the event, it means the event over the sample space. Here, I want to calculate the probability of sample space itself. So I put it over the sample space. It's the same. So S over S sample space over sample space equals 1. The next, if a dice is tossed once, then probability of getting an even number equals, yes, here, a dice tossed once. So that means the sample space equals 6. The probability of getting even numbers, we said even numbers from 1 to 6, they are 3 numbers. So 3 over 6 equals half, 0.5. The next one, when tossing a die once, then probability of getting a number divisible by 3 equals, okay, and also the dice, I want a number divisible by 3. 1, no. 2, no. 3, yes. 4, no. 5, no. 6, yes sir, I have only 2 numbers, 3 and 6, who divisible by 3. So, they are 2. The event here equals 2. Number of events equals 2. 2 over 6, it means 1 over 3. 1 over 3. Okay. The last one, when tossing a coin once, then probability of getting a head is, yes, we said it before, when tossing a coin, the probability of getting head, yes, head, equals what? Equals half, okay? Or here, 0.5, or it's 50%. Okay. Here, if you see in your lesson or in your book, in the experiment of selecting a card randomly from 7 equal cards numbered from 1 to 7, write the sample space, then find the probability of. Okay, what is the random space here? There are 7 cards numbered from 1 to 7. That means the sample space equals 1, 2, 3, 4, 5, 6, and 7. Okay? Event A, where A is appearing a number less than 4. Probability of this event, event A, I want the numbers less than 4, which are 1, 2, 3. 3 over 7. And 3 over 7, this is the simplest form. 3, the number of the event here, 1, 2, 3, the number is less than 4, and the total number or the number of sample space equals 7. So they are 3 over 7. Okay, the next one here, the event B, where is appearing of an odd numbers. Okay, let's see the odd numbers from 1 to 7. 1, 3, 5, and 7. They are 4. 4 over the sample space 7. So here event B, the probability of event B equals 4 over 7. The next one, the event C, where C is appearing a number more than 5. 6 and 7. 6 and 7. So the number of event C equals 2. And the sample space equals 7. So the probability of event C equals 2 over 7. Is it clear? Here, all the experiments are the same idea. Okay? So, please practice more, solve your book, the exercise in your book. I hope that you enjoyed the session. Thank you so much, and let's meet in another lesson, inshallah. Goodbye.